The final part to our multiplying fractions segment is going to tackle something we haven't seen yet here. Mixed numbers. Now, is this a different rule to what we've learnt so far? Perhaps it's the same rule, but we just have to work out how to use it. Let's have a look. I'm going to give you a common answer that students give, which unfortunately is wrong. But it is not a silly idea, it's just not correct. Students do the following. 3 times 1 is 3. Then they do 1 times 4 is 4. 2 times 7 is 14. And then they simplify it to get that. Now, the reason students do this is, when we had adding fractions, for example here, you would add the integers and you would add the fractions. So why doesn't the same rule work? Well, we have to cast our minds back to how to multiply in order to show this. So let's look at the sum 17 times 12. I'm going to show it using a grid method. Now, if this isn't your preferred method, that's fine, but it should help you visualise the problem. 17 is 10 and 7. 12 is 10 and 2. 10 times 10 makes 100. 10 times 2 makes 20. 10 times 7 is 70. And 7 times 2 is 14. Now, you add those parts together. Okay. Now, what you're thinking now is, this is nothing to do with multiplying numbers. Fractions are numbers. So let's draw a grid. 3 and a half. 1 and 4/7. Let's write that larger for you. Now, in our wrong effort earlier, we did 3 times 1, multiplied the integers, and then half times 4/7, multiplied the fractions. 3 times 1 is here, so that sum was correct. A half times 4/7 is here, so that sum was correct. Have we done the entire sum? Well done for spotting that we haven't worked out 3 times 4/7 and we haven't worked out 1 times a half. And these two bits are what you miss off when you do the method up here. So, how can we avoid this problem? Well, all of our fractions we looked at previously are a different setup. There's no mixed numbers here. No mixed numbers. Even back to the beginning with the really difficult numbers. But in this kind of format, what's to stop us from writing a fraction where the numerator is larger than the denominator. What's to stop us from taking 3.5 and writing it as 7/2? If you need to go back and re-watch the mixed numbers to improper video, I suggest you do that now, because it will be a crucial skill for this section. And this one, 1 whole one, is 7/7, plus the extra 4 is 11/7. Now it looks just like our previous problems. And so we would be expecting our rule that you multiply the numerators and then you multiply the denominators to work. Before we do that, I'm going to say to you, C. Well done, that's cross-cancelling. So we're going to write 7 times 11 over 2 times 7, and we're going to divide both parts by 7, which makes it 1 times 11 and 2 times 1. So it's 11/2. You may wish to write that like that. You don't have to unless the question specifies it. So when you have mixed numbers, convert them to improper fractions and do exactly what we've done before. Now, why does this work? Well, let's take a look at our error here, which was that some bits of our number were not multiplied correctly, like in the number grid. Now that we have it as a mixed number, all of these bits, which is all of this, gets multiplied by all of this. So the 3.5 together makes the 7. It's not 3 times the 1 and the half times the 4/7. The whole thing is 1. So there's no missing off of any bits. Let's try one more just to practice. So first step, let's get them into improper. Each of the 5 whole ones is made up of 4 bits, so that's 20 bits plus the extra 1. Each of these whole ones is made up of 2 bits plus the extra 1 is 5 bits. Cross-cancelling. Now, the reason I've picked this example, other than to go through that first step again, these two could cancel, but they're both on the denominator. You've got to cancel the top and the bottom of the fraction. Those two don't cancel. Neither do those two, or those two, or those two. So in this case, there is no cancelling. I think at this stage, you'll probably want to practice this skill a lot more. So, worth going away and doing 10, 15, 20 questions. Make sure you're up to speed.